right, our second lesson in Unit 5 is slope. Right, let's run through our standards. We are preparing for 8EE5. That is, again, graphing our proportional relationships. And our mathematical practices are making sense of problems, persevering to solve them, constructing arguments, critiquing reasoning, and modeling mathematics. Okay, our question, why are graphs helpful? I'm going to try to figure out why having a graph of an equation is helpful to determine answers to our questions, figure out what the slope is. And what you're going to learn today is you will understand slope by the time you're done, and you will be able to determine the slope of a line from a table or a graph. We have 3 vocabulary words in this lesson. So the page that you created on lesson 1 for vocabulary, these words are going to be added to that page. All right, so our first activity in lesson 2, let's take a look at our definition of this thing called slope. The term slope is used to describe the steepness of a straight line. Okay, so when you're writing your vocabulary, when you have slope, this first piece of information is actually very important. Yeah, that's good to have the official definition, but this is straightforward. The basic, if you know this line, things become a lot easier and make a lot more sense. The term slope is used to describe the steepness of a straight line. Okay, it's like a ski slope. If you've ever heard of ski slope, take a chair lift up, go at the top, and you ski or you snowboard down. Some ski slopes are steeper than other ski slopes, and that's the same thing as slope. Okay, it's the steepness of a straight line. Now, the official mathematical definition that you'll see is slope is the ratio of the rise or vertical change to the run or horizontal change. Now, again, this first piece should make more sense to you. This official definition may not make sense right now, but it is the official book type definition. Okay, so both of these things probably should be in your definition for slope. Now, the definition for rise and run, those were the 2 other words in your vocabulary. So if it was me on your vocab list, I would say rise is the vertical change of a line. The run or horizontal change of a line. So again, in your vocabulary, for slope, we change colors so you can decipher here. For slope, the whole thing. Okay, so the slope definition will be this entire blue box. Okay, for rise, you'll have rise is the vertical change of a line. And then for run, use the run is the horizontal change of a line. Okay, so now that we're clear on those words, you're going to complete the graphic organizer. So looking at the word slope, I think this word means blank. How is this concept related to other math concepts? Where have I heard this word in my life? And what makes this an important word for me to know? Okay, so I want you to fill these 4 boxes in. A couple things. I think this word means, I'm not looking for enough, don't put a definition down. In your own words, from the definition and from the little intro I gave, put it in your own words what you think slope is. This one down here, see if you can come up with something other than ski slope. It's one I gave you. Think about in real life where things happen where you'd have a steepness or a flatness that would be comparable. So, like I said, on a ski slope, some, the expert trails are very steep, the bunny hill is very flat. So think about other things in your life where there's a steepness or a flatness, okay? So fill each of those 4 boxes below before you move on. Okay, our first section here says to find slope using a graph or a table. Okay, so we're actually going to get a number that represents a slope. So we'll find a number that represents the steepness or the flatness. Slope is a rate of change. It can be positive, slanting upward, or negative, slanting downward. Okay, we'll look at that again in a minute. Slope equals rise over run. Okay, this is very important. Slope equals rise over run. This would definitely be something to circle, highlight, put a big star. Okay, the next at least month or two, this slope is going to be something that you need to memorize, you need to know. It will be very, very important. Slope equals rise over run. Now let's take a look at the rise. The rise is the vertical change between any 2 points. Now, last activity, lesson 1, we looked at a constant rate of change. And when you looked at the constant rate of change, we compared the y coordinates. So we looked at 2 y coordinates and we subtracted them. That is the vertical change. The run is the horizontal change. And that was when we subtracted the x's. Okay? So when you had a y minus another y, that was our vertical change. And now the little 2 and the little 1, let me explain that. What will happen is when you do operations with your ordered pairs, this is a mess, let me fix it. You have 2 y coordinates. You have the first y coordinate and the second y coordinate. And it's just labeling which y is which. Because what happened is when you did your denominator and you had your x's that were subtracted, if you started with the second x minusing the first x, you started with the second y minus the first y. And we'll get to that a little bit more in a minute too. But add a little note to this rise over run. Oops. Add a little note to the rise over run. Add some little arrows and show this y2 minus y1 and x2 minus x1. Okay. Hopefully yours is less messy. Okay, so keeping this rise over run in mind. Okay, they call it rise over run just as a way to associate what's happening. The rise is a vertical, so if something's rising up, it's going up and down. Okay, a drop would be a down, a rise would be up. Run, if you run left or right, that's a horizontal movement. So those are just the words that they associate so that you can keep in mind the way that the movement is happening. Okay, let's take a look at an example. It'll make more sense in action. Number 1, find the slope of the treadmill. Slope equals rise over run. Okay, now right here it tells us the rise is 10 inches. Here's our rise. Okay, it's how far it goes up and down. And our run is 48. Okay, so on in your notes, I want you to label these 2 things. Rise, run. Okay, so label the rise, label the run. If we look at our fraction, our rise is 10 inches, our run is 48 inches. And when we simplify that, we divide each by 2, we end up with 5 over 24. So the slope of the treadmill is 5 over 24. The reason that we would have this, why we would even need this slope, like what's the point? If I were to take my treadmill, let me find a color that's going to show up easily for you. If I were to take my treadmill, this line right here, okay? If I were to take this line and I wanted to extend it and keep going at the same exact steepness, I could use that rise over run to determine the rest of my line. Doesn't make sense on a treadmill, but once we start looking at graphs and other situations, it will make sense. But the point of having a slope is if you know the steepness of a line, you can predict where the rest of the line will go. It's about making predictions, finding a pattern, making a prediction. Okay, so let's take a look at the example that they have down below, the got it, try it yourself section. Right down here. A hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope? So rise is 6 feet for every horizontal change of 100 feet. Okay, so if we have rise over run, our rise is 6 feet. Our run is 100 feet. Okay, so next to this problem, write rise over run equals 6 over 100. Okay, if you want to add more notes, you could also, now again, you know yourself, you know how much you need. Definitely the what's in blue. But if you want, you could circle this and label that rise if you wanted to. You could, I wish they'd put this together, but you could take this and call that the run. You could color code. You know, you could, if you like the rise in blue and the run in red, you know, you could take a red pen and you could circle this for the run, or the rise. And in blue, that's the wrong color. Red would be our run. If you look at the, 100 feet for our run. And then for blue, we would have our rise. It's up to you, okay? It's not that big of a deal. It doesn't have to be a big production. Rise over run is really the one thing you need to remember. So if color coding is going to help or not, it's up to you. Now the thing about our rise over run, which is 6 over 100, we do need to simplify the fractions. So both of these are even numbers, so they're divisible by 2. If I get my pen to write. So 6 divided by 2 is 3. 100 divided by 2 is 50. Now a couple notes about slope. Always simplify. Okay. And the other thing that you do need to know is if you end up simplifying it down to like something like 3 over 1, you would write it as 3. However, we are dealing with a rise over a run. So if you ever see a whole number for the slope, you can assume the run is a 1. Okay, so if you never leave it improper, like a 3 over 1, you'd answer it as you'd write your answer with a 3, but you do need to know if you ever see a whole number with the slope, the run is always 1, okay? So if the slope is a whole number, okay, so if the slope is a whole number, the run is always 1. Okay, if you need an example of that, if the slope is 4, you would rewrite it as 4 over run, the rise would be 4, the run would be 1. Okay. The other thing, never, that says never write slope as a mixed number. Okay. The reason is because we need a rise over a run. There's no room for whole numbers here. Okay, it's a number for the rise and number for the run. So if you end up with something improper, you leave it improper. The things aren't improper anymore. There's nothing wrong with a fraction where the numerator is larger than the denominator. We're past that. It's okay. All right. Do not feel like you have to make numbers mixed. Slopes are not mixed. Okay. Numerator, denominator. Rise over run. Okay, next example, number 2. The graph shows the cost of muffins at a bake sale. Find the slope of the line. Okay, so what we're going to do is we're going to choose 2 points on the line. The vertical change is 2 units. The horizontal change is 1 unit. So I want you to take a look over at our graph. Now, if you had, in our last example, you were given a number. You were given the rise and you were given the run. The rise was 10, the run was 48 or whatever it was. Okay, rise is 6, run was 100. And now you're not given that information. You're given 2 points. So we have to decide on the rise ourselves. So let's take a look at what's happening on our graph. our rise here is 2. Okay, when you are counting your rise, you move like a game board. You don't count where you start from. You count your first jump. 1, 2. Okay? And you can write that. What ends up happening is you end up creating kind of a triangle. Okay, so my rise is 2. My run is 1. So another way to look at this is start at one point, and you're giving directions from one point to the next. So I'm giving somebody directions from this first black point to the second black point. The only trick is you can only move vertically and then horizontally. So if you had to give instructions to get from one point to the next, only moving vertically or horizontally, what directions would you give? You would tell the person to move up 2 spaces and to the right 1 space. You would tell them to rise 2 and run 1. Okay. That's all you have to do on any line. This works. Let's take a look at another part on this graph. Okay. Let's go from this point, from 0, 0 to 1, 2, and see if that still works. Is the rise over run 2 over 1. So if I was going from my first red point to my second, I would rise 2 and I would run 1. Rise 2, run 1. Rise 2, run 1. You see how that's the same pattern over and over again? Looks like little stair steps I'm creating. Okay. Rise 2, run 1 every single time. Couple tips off to the right hand side. Up is a positive movement. So if you have a positive run, you would move up. If you have a negative run, you move down. To the right, so if you have a positive rise, you move up. If you have a negative rise, you move down. If you have a positive run, you go to the right. A negative run, you go to the left. So if you think about temperature on a thermometer, when the temperature rises, it moves up. When the temperature drops, it moves down. Okay, if you have negative degrees, it's down below 0. All right. On a number line, to the right of 0 is positive, to the left of 0 is negative. Okay, so these are movements that you've done before. You should be familiar with the positive and negative movements. Okay, one little side note that I want you to think about. You don't have to write this down, but if you have a fraction that's negative, what you'll see is the negative sign is written out front. Okay, so if slope was negative 1/2, here's what you have to decide. You decide, is the rise negative or is the run? Okay, only one of those numbers can be negative. They're not both negative. Either the rise is negative or the run is negative. If they were both negative, a negative divided by a negative is a positive. So if they're both negative, you're undoing itself. So if you have a negative slope, and we will see one in a minute, if you have a negative slope, you have to decide, do you want the rise to be negative or the run? That's something that you can create a rule for yourself and follow it every time, or you can kind of play it by ear and decide sometimes it's better to have one negative than the other. And you'll see as you go through. But this is an important little note. If you can fit this on your paper, we will be using the sidebar area in just a second, so do not write in this area. Okay, but if you can find a place to jot that little note down, that if your slope has its negative fraction, one of those two numbers is negative, not both. Okay, now something else to talk about. Let's say you are working with your friend and they think the slope in this example is 1/2. How could you explain to your friend their error? So your friend says, no, the slope is 1/2. Describe the error to your friend. In this sidebar area, I want you to write down, what would you tell your friend? How would you convince them that they're wrong? How would you convince them, no, the slope is 2 over 1, it's not 1 over 2? So in this little sidebar area, just let me know how would you help your friend out with their misunderstanding. Okay, number 3. The table shows the number of pages Garrett has left to read after a certain number of minutes. The points lie on a line. Find the slope of the line. Okay, so that's a little bit different. We've seen when you've just been given the numbers, then we looked at a graph, and now we've got a table. So our process when this is our situation. Step 1. Okay, so if you want to, label these as steps. Step 1. Choose any 2 points from the table to find the changes in the x values and the changes in the y values. Now on our graph, we were able to draw that little triangle and draw how many we rose, how many we ran. Okay, in this case, we're just going to focus in on 2 ordered pairs. Okay, you could use 3, 9, and 5, 6. This example, they used our first 2. So all we're going to do is we're going to focus in on these 2 ordered pairs. We're going to completely ignore these others. Okay, so change in y. That tells me we are going to focus on these 2 values right here. So we want the change in y. Anytime there's a change of something, we're trying to find the difference. Okay, the distance between those 2 numbers. All right, and that gives us a subtraction problem. So 9 minus 12. Okay, usually one thing that you're going to notice is the second y is subtracted, or it's second y minus the first y. That's where at the beginning I had that y with the little 2 and the y with the little 1. A lot of times you'll see they start with the second y and start with the second x. You could do either way, okay, and I'll show you right now. I could have done 12 minus 9 instead, okay, and we'll see this work out in a second. So now let's look at our change in x's. Okay, so our change in x will be right here. And that's going to be 3 minus 1. So in our example, okay, so ignore mine for a second. In our example, what they looked at here was they took the change in y, which was 9 minus 12, okay, and then our change in x, 3 minus 1. What I want you to notice is, do you see how we started with the second values? Started with the second y, which was a 9 minus 12, second x, which was a 3 minus 1. Okay. And what you end up getting is 9 minus 12 is negative 3, 3 minus 1 is positive 2. Okay. Now they rewrote that. See how the negative sign was pulled out in front? Okay, in our math work, the 3 was negative and the 2 was positive, so my rise would be down 3, my run would be over 2. Okay, and it actually could go either way. Here's what I want you to look at. If I looked at this table and instead of 9 minus 12, I wanted to do 12 minus 9. Okay, so if I want to say, well, my change in y is going to be 12 minus 9. Okay, what that means is for my change in x, do you see how I started with my 12, which was the first number in the ordered pair? That means for my x values, I have to start with the 1. So when you pick your 2 points, it doesn't matter which y you start with on your subtraction problem, but you need to know if you start with the second y in your numerator, you have to start with the second x in your denominator. You can't pick and choose the order for both. You pick the order and you stick with that order. So if you start with the first y, so if it's the first y minus the second y, it's over the first x minus the second x. Okay, so first y minus second y over first x minus second x, or second y minus first y over second x minus first x. Okay, and that comes into play the notation that you saw me do at the beginning where I said y2 minus y1. That stands for second y minus second 1 over second x minus first x, or first y minus second y over first x minus second x. You can vary this from problem to problem. Just be very, very careful that these two are an ordered pair. These two are an ordered pair. Okay, you can't jump around. Okay, so you may need to pause this if you can find a space, whichever section makes sense, written like that or written like this. Pause it and get something copied if you need it. Okay. Let me make myself some room here. All right. Now, what you'll notice, let me come back up here to the 12 minus 9. 12 minus 9 is 3. 1 minus 3 is negative 2. Now, if you notice, in this example, my 3 was negative. In this example, the 2 is negative. And in the last problem, I said it doesn't matter which number you make negative, but one of them has to be negative. Okay? And what you would see, and you don't need to copy this down, but I want you to see something for a second. Okay, I'm going to plot this a couple points really quick. Okay, let's see what I have here. I want to use some smaller numbers. So let me look at 3. Okay, I'm going to look at 7, 3. So right about there would be 7, 3. If I extended this out. Okay, so let's say that's 7, 3 and 5, 6. Right about there. Okay, if this was a grid, okay, bear with me. Okay. So here are my 2 points. All right, don't write this down, just watch. Now, if I went from point to point, I want you to look at what happens between these two numbers. If I wanted to start down here at this point, and I want to rise, I would rise 1, 2, 3. And when I run, I would run backwards, 1, 2, which makes a negative 2. And this would say my slope was rise 3, run negative 2. It gets me from point A to point B, right? Good. Now let's look at it the other direction. What if I wanted to start up at this point and get down to the other? Well, I would go down 1, 2, 3. I would go down 3, and I would run over 1, 2. That would be negative 3 over positive 2. Either set of directions gets me to the same point. It depends on which number you make negative. It answers the same. So that's just a way to prove to you that it doesn't matter which order you go in, as long as whatever you start with the y's, you have to start with the matching coordinate on the x's. Okay, it was a lot of information. Let's take a look at some examples. Find the slope of each line. So for B, we're going to start at one point and work our way to the second point. Okay, so let's say we started at this point, and I need to get to my other point right up here. So I'm going to rise how many? 1, 2, 3. And I'm going to run 1, 2, 3, 4. So my slope would be 3 over 4. Now let's use what I just got done doing a minute ago, and let's get from this point, the top point, to the bottom point, and let's see what happens for a second. I would drop down 1, 2, 3, so I would go down 3. I would go backwards 1, 2, 3, 4. And it would be negative 3 over negative 4. What's a negative divided by negative? It equals a positive. So this would actually simplify to 3/4. Same exact slope. Keep that in mind. Okay? Doesn't matter which direction you go in, as long as you rise first and run second, you're good. Okay, I would definitely make sure on B you include each of these 2 examples. Now for C, we have, let's focus in on 2 ordered pairs. Doesn't matter which ones you use. Honestly, if it was me, I'd kind of keep it towards the middle, or maybe go with the positives. Totally up to you. These are the 2 I'm going to pick. If you want to pause it and try it on your own, definitely do that. Doesn't matter which 2 you choose. we should all get the same answer. So pause and see how you do compared to me. All right, no matter which two ordered pairs you chose, you should end up with 1/4 as your answer. Okay, I chose these last two here, so I would say my y's minus each other. So I took my second y minus the first y. So that means I have to take my second x and subtract the 2. So 1 minus 0, 6 minus 2. Now again, you could have done any ordered pair that you wanted to here. If I wanted to take these two, I would say pick a y. Let's say I picked this one, the -2 first. -2 minus 0 over. If I started with -2, that means I have to start with -6. -6 minus 2. -2 minus 0 is -2. If I add the opposite on my denominator, I get -8. That simplifies to positive 1/4. If you're unsure how I got there, 2/8 simplifies to 1/4. Negative divided by negative is positive. So no matter which ordered pair you pick, you're going to get 1/4. So my answer for B would be 3/4. My answer for C would be 1/4. And skip that question. If you want to add it in, you can. We took up a little bit of space. This video is starting to get kind of long, so if you want a quick rewind and flash up to that question and answer it, go for it, but I'm not stressed about it. Okay, at this point I want you to stop. Okay, do not cross out the slope formula section, but we're going to come back to that. Okay, so we will come back to slope formula, not right this minute. Okay, little review of our vocabulary. Make sure that in your notebook you have a vocabulary page for Unit 5. It has the few words from Lesson 1, and now these 3 words. Okay, go ahead over to your guided practice section. And let's look at numbers 1, 2, and 3. Okay, number 1, find the slope of the storage shed's roof. So if we focus in right here on the storage shed, it actually tells us that 3 feet is the vertical change, or the rise. 15 feet is the horizontal. So my rise is 3. My run is 5. It's my slope. Oh, not 5, 15. Okay, number 2, find the slope. We have 2 points here. You can find your slope going any direction. They give you an example here. You can use this absolutely. And what we get is our rise. Now, let's run back through this for a second. Because they're going in this direction, don't get fooled into running first. Okay, that's the red part. But look at the blue. You always rise before you run. Okay, if you think about it, if you're sitting in a chair and something happens and someone walks by and smacks you on the head and you want to go smack them back. You're sitting in a chair and something startles you and there's a dog coming to chase you and you need to get away. You don't scoot around the room in the chair and then get up. You get up first and then you run to either chase your friend or to escape the dog. So you rise out of the chair before you can run away from the situation, okay, or run into a situation. So in this case, I need to choose a rise first. In example or problem number 2, my rise is actually going to be negative because I'm going down 1, 2, 3, 4 places. And then my run is actually, I'm going to the left 3. That's a -3. Now, I personally would not have gone that direction. Okay. For me, I usually tend to start on the point that's to the left side and then move to the point that's on the right. But that's just how I do it. Doesn't make it right or wrong, just makes it how I do it. You can do this anyway. If you would rather rise first, so if you would rather start on the left, you would rise 4, you would run 3. If you look at this either way, 4/3 is my slope. If I use the numbers in black, the only difference is you get -4 over -3, which actually equals 4/3. Okay. Number 3, we have sets of ordered pairs. Pick whichever 2 you would like. Okay, add a note that you can pick any 2. And what I also want you to write is I want you to write this formula down. If you write this down for a few problems, it'll start being ingrained in your brain. So second y minus first y over second x minus first x. So my second y is a 3 minus so 3 minus 1 over second x minus the first x. I end up with 2 over 1. Slope would be 2. Just to prove it to you, let's take a look at 2 other numbers, just in case. Let's say I took these. Second y minus the first y, so 7 minus 5 over second x minus the first x, 3 minus 2. Again, if I look here, 7/3 is an ordered pair. If I look here, 5 over 2, or 5 and 2 is another ordered pair. Okay. And 7 minus 5 is 2. 3 minus 2 is 1. I get 2. So no matter what, my slope is 2. Okay, the remaining problems in the guided practice you're going to pause and wait on. We'll come back to that. Okay, so these 2 wait on. Do not do those yet, unless you want to try. Okay, there is a self-check. Do the problems that match what we've worked on if you want to test yourself. And finally, the next post will have the problems that you need to work on in the packet. That's it.